Hi everybody, Bill here. Short presentation. I'm going to try and keep it short and sweet. It's all about urban settlements in Africa. Without getting into too much detail, this is what's going to happen. Africa will host the 10 fastest growing cities in the next 2 decades, and most of it will be in the form of informal settlements. So it's coming, and it is a concern for a lot of people. As a chemical engineer, we'd like to think of systems or processes so we can draw a boundary around an informal settlement. Okay. And what we say is we define the water in and the water out as defining the boundary. So you have a certain catchment area and you have a certain downflow. And what basically happens is water will enter the system and water will come out. Important to understand here that the water that come out, how clean it is, that's the big issue. Okay. So on to the next slide. We have to do a little bit of background in terms of what is biomass. Biomass, is plant material, food waste, manure. It's organic material. And basically, like all material, it consists out of elements, the most important elements being carbon, hydrogen, oxygen, but of course there's more elements that sustain life. I've just named a few here: nitrogen, sulfur, phosphorus, potassium, magnesium, calcium, etc. So I'm just going to work with these main ones. Important when you look at biomass is to split it up. The first three elements, C, H, and O, carbon, hydrogen, oxygen, is really more related to producing energy. So of course, from biomass we can make a lot of energy. You know about anaerobic digesters, or just plain burning wood or burning plant material, or even eating material and getting energy. That's the way humans get their energy from. But what's very important is there's another part to biomass, and that's what I like to call the carriers. Okay, these are the minerals or nutrients. I see I've got a spelling mistake, they're nutrients. Okay, so these carriers are required. If we don't have the carriers, we don't have the biomass. We can have all the sunshine in the world. If we don't have the carriers, we can't capture the energy from the sun to make food, and we can't eat, and we can't make other energy forms from that. So it's important to distinguish between the carrier part of biomass, like we have here, and the energy part. Keep that in mind. I'll be talking about carriers for the rest of this presentation. Okay, so if we look at the informal settlement, it's not just water coming in, because people living there, they'll bring a lot of stuff into the vicinity or within the boundaries. And one important thing that they will bring in is food. Okay, they've got to eat. They'll probably eat most of their food within the settlements. And then what happens is that food gets processed by their own bodies. It gets excreted. It stays within the vicinity. And long story short, in the end, it ends up in the water. Okay, what ends up in the water is just the carrier part. The carrier part ends up in the water. The energy part, of course, is used for humans getting energy, and you can even do more with that. Okay, important to understand this. So, in terms of spilling carriers into the environment, okay, that's the big thing here. What does water with carriers that we spill into the environment do? I don't have a lot of detail to get into eutrophication, but basically it's nutrients. It's carriers that sustain life. If we just spill this into the environment, the effects are detrimental. We know that, especially over long periods, because we supply food to other ecosystems and it's unbalanced. The result is biodiversity loss. Okay, if we are reckless with our carriers, we really harm the environment severely. So that's why we want to minimize the amount of carriers that goes out into the environment. Okay, so nature is the big teacher. Okay, and very important. We always want to learn from nature if we want to approach sustainability. Very important. So how does nature work? Nature has this beautiful way of recycling. So if we talk about the carriers within a natural system, clean water comes in and clean water goes out. Okay, so there we have it. Clean water coming in and clean water going out, because effectively what's happening is that there's a major recycle of the carriers within the boundaries that we've defined within that ecosystem. Okay. Next, so I've explained this. Nature basically gets its carbon from the air, water, It's in sunshine, and there you have it. You can grow as long as you have carriers. But nature has this beautiful ability that developed over eons of recycling the carriers within a closed system, okay, or ecosystem. Very important. So now we get back to informal settlements, and what we want to do is we want to mimic what nature does. That's the way to go. That's the way to approach sustainability. So what we have here is that people eat. Of course, they eat within the vicinities. Now, as soon as people eat, you generate, I don't know if you see this icon, this is food waste, and of course, the waste from humans itself, urine and feces, okay? So, of course, from eating, you get a lot of energy. That's why we eat. We need the energy. And, of course, we can use the food waste and the human waste in creative ways to create more than just the energy that humans need to survive. We can use anaerobic digesters, make biogas, and we can, cook our own food off the biomass that has this energy component. So there's obviously options to generate more than the energy that humans need. That kind of takes rid of the CHO part of the biomass. But the carrier part remains, okay? So the carrier part remains. And the clue from nature is we got to recycle the carrier part. How do we recycle the carrier part? We grow plants. Plants has this amazing ability. It's really, if I talk about carriers, I say carrier, we can call it fertilizer. Plants require those carriers or fertilizer to grow. So if we have those carriers within the system, the plants can take it up. Okay, and now the next slide is as soon as we have plants, of course, if we have plant material, we have energy and we have carriers. Okay, what to do with the plant material? And the big question here is, do we need to grow edible plants, or is it better to go with non-edible plants? And that's what it's, that's what I'm trying to answer. So look at the green arrows here. If you look at the green arrows, if we grow edible plants, that goes back to the humans through their system, and then the cycle continues. If we grow non-edible plants, we're not feeding it to humans, but we can get the energy from it. Okay, very important. So the objective here, the objective of this whole exercise is to minimize the carriers that go out. Okay. Now, I'm not going to spend too much time on explaining steady state, but I'm a chemical engineer and you'll just have to believe me. And that is whatever comes in, what comes in here will go out here. So if we look at only the carrier part, let me try and do, I'm still struggling with my mouse. It's not the CHO part, it's the carrier part that we're interested in. Okay, so by reducing what we put in, we're reducing what we put out. Okay, so I'm just gonna go on to my next slide, and here you will see that I've got a big green arrow. That implies that we are growing a lot of edible material within the vicinities of the informal settlement. Okay, of course there'll always be food waste and there'll be human waste, so the energy component from that biomass is not just for eating, but at least it has an eating component. The argument here is, how do we reduce, you can see I've got a little small carrier fraction here and a small carrier fraction here. How do we reduce it? Now, it is self-explanatory. If a part of our diet comes from what we grow within the boundaries of the system, okay, that implies that we're growing our own food. There's advantages to that. It's nutritious, it's for free, or at least very cheap, compared to buying the food. But the advantage I want to explain here is, if we eat the food that got grown from carriers that got into the system and we recycle, we effectively have to eat less other food. So there's less food flowing in the system if you grow your own food within the system. Okay, and that gives us the answer, because if you grow less food, you take in less carriers, and the steady state principle apply. Less carriers then will go out into the environment, and that's really the big advantage in terms of sustainability. Of course, if you are not eating, if we not go with this green arrow, but we only grow, they talk about phytoremediation, you can capture those carriers with a plant that you can't eat. And of course, that plant Plant material then has a lot of energy, so you can make more energy of it. But the problem is what happens to the carriers. The carriers stay in the system. If the humans aren't eating it, you will basically not really be reducing the carriers that you spill into the environment. Okay, so I'm finished. To conclude, the way I see it is the more food we grow within the boundaries of that informal settlement, the less carriers we will release into the environment. And that, from a protecting Earth point of view, is very significant, because we don't want to spill carriers recklessly into the environment. So this is just a short video to make the argument that we want to grow edible plant material to recycle carriers within the environment. That's it. Thanks.